if we are dividing radical expressions, we have to understand that they can come in potentially two different forms. They could come in the form that you see here, where there is a quotient inside of a radical, or they could come in the form you see here, which is the quotient of two separate radicals. Generally speaking, when it comes to simplifying these, it's a matter of recognizing what form you are in, and then most of the time you are changing it to the other form. So in this example, in our first example, we have the quotient, the radical of a quotient. In order to simplify this, we're going to split it into the quotient of two radicals. And we're going to consider the top and the bottom, the numerator and the denominator, as two separate radicals. The square root of x squared is, of course, just x, and the square root of 25y squared is just 5y. I wouldn't have been able to get that from up there. I couldn't do anything with just this radicand. So I split it into two, and I separate, and I simplify from there. In our second example, we already have the two separate radicals. I could do some work here, but it's going to be easier for me to simply just imagine combining these two together and doing the simplification from there. So I'm going to take those two radicals, combine them into one. This will turn into 20. This will turn into x to the fourth. So my new version is 20x to the fourth. I know that the square root of x to the fourth is x squared. I know that 20 has the perfect square that goes into it of 4, leaving behind a 5. So we take the square root of 4, and we leave behind the 5. Two different routes for two very similar looking questions. And again, the goal was 99% of the time, the goal is going to be whatever form it's in, move it to the other one, and then ideally simplify. This example is a perfect case of that. We have a cube root that we're going to combine the radicands into 1. So in our numerator, we have x squared plus 7x plus 12. Those parentheses are a little redundant, but it's nice to keep everything grouped together. And x plus 3 in the denominator. If the cube root wasn't there and you were simply handed this radicand and told to simplify, you would jump right to our work with rational expressions and say, well, I need to factor this so that I can look for some kind of simplification with the denominator. And we get one pretty quickly, leaving behind the cube root of x plus 4. We only got to this point because we took the two radicands and combined them into 1. Could you have done that work with radicals around everything? Sure, you could have done that work with radicals around everything. You could have factored this numerator and then separated it into two different radicals and then crossed those two radicals that were the same from the numerator and the denominator, but staying with our tradition of combining into 1 and then simplifying on the inside, that's a little bit of a stronger technique in general. One last example that's going to use a similar skill. We'll do the same thing with the cube root. We'll put together our insides, resist the temptation to just start scratching out A's and B's. That radicand is a rational expression. This must be simplified with factor and cancel. It cannot be simplified any other way. So we leave our cube root. We remember our process for factoring the difference of two cubes. Oops, I forgot a square. Knowing that we're probably going to want to simplify with what's in the denominator, a minus b's are going to go away, leaving us with the cube root of a squared plus ab plus b squared as our simplified form. So division is a matter of what form are you in and then attempting to get it into the other form. Sometimes that results in separating the radical into two separate radicals that can be considered individually. And sometimes that consists of taking two separate radicals, combining them into one, simplifying the radicands as much as you can, and then taking the radical from there. Depending on what you are provided at the beginning of a question will determine the route you take to solve.